Hello, welcome to the first lesson on integration. So if this is the first time of you watching a video on my channel, kindly subscribe for more videos. If you're a fan of my channel and have not subscribed yet, kindly do so for more videos in the future. Alright, let's start. So integrations. Alright, if you could remember in our previous videos on differentiation, we said something like if you have a function that you want to find the derivative of the function at a point that is a small change, okay, of the function y with respect to x in terms of a function where we have y is equal to x to the power n, that is a polynomial function, then this derivative is equal to n times x to the power n minus 1, okay. Alright, this was it, right? So now let me ask this. If I have something like this, okay, this one, and I want to find this parent function back, what do? That is where we use integrations, okay. So integrations actually comes into play when you are dealing with finding the function that when you differentiated we had something like this. So integration will take the derivative back to its original function, okay. So in effect, we know that for differentiation the operator that we use is dy dx, okay. Now for integration too, we use what we call the integral sign, okay, of a certain function that we don't know, okay, of the function dy dx, okay, dot dx. Alright, so if you could see this, then this means that it's as if you are multiplying what we call the parent differential, okay, because dy dx will actually give us this dy dx. Let me write it better, okay. This dy dx will actually give us what? N x to the power n minus 1. Alright, so if I come and put it in the integral sign, I get something like n x to the power n minus 1 then dx, okay. So now we want to make sure that after everything we get this parent function back. So what do? Alright, so let's try to manipulate the function inside the integral sign, okay. That you are coming to manipulate this n x to the power n minus 1 and see how do we manipulate it to get y equals s to the power n, okay. So this actually we want to find our parent function back. So alright, let's try to add something to the powers, okay. If I add something to the power, let's say if I add 1, because for differentiation we subtracted 1, then if you want to have the power back, what do? We add 1 back to this, okay. Now the actual power was n, and when differentiated we had a power n minus 1, and so if I want to have my n back, I have to just add 1 to this, okay, and I'll get what? N. Okay, so adding 1 to the power will give us what? N x to the power n. But just so there wasn't any n in front of the x for the parent function. So what do? Let's try to divide, because it's like this, okay. Let's be fair here. I'm coming. Alright, so if you could remember, this was the original function. Now we pre-multiply the function by n and you subtracted 1 from the power, okay. We want to find this y equals x to the power n back, okay. That is why we said you have to put the derivative, okay, inside y is equal to that is what we want to do for integration, okay. So this is equal to, now we put back our derivative x n minus 1 dx, okay. Always when you're integrating a certain function, it means you are integrating some differential, okay. That is how it is. When I say integrate f of s, it means that there was some function that after differentiated we had f of x. So integrating that will give us the function back, okay. So now for the differentiation we subtracted 1 from the power n, okay. Now for integration you have to do the reciprocal of it. So for integration it's like your dy dx, let's call it, let's say g, and it's equal to n x n minus 1. Okay, so if I want to get my function back, I have to do the reciprocal things that we did for differentiation. What I mean is that for differentiation we subtracted 1 from the power. Now the reciprocal of -1 is +1. Okay, so what we'll do is, to get our function y back, this we just add 1 to the power, so n minus 1 plus 1. Okay, then since for the differentiation we multiplied the front, or we pre-multiply the function by the power n, or the original n, let's divide the whole of this, okay, by the new power that you've gotten, okay, n minus 1 plus 1. Okay, and now this is equal to n x to the n over n, and this is equal to what? X to the n. So now we've been able to do something to the differential, this one, to get our parent function y equals x to the power n back. So now this comes to writing a general definition for integration of polynomial functions. Okay, alright, so if I have a polynomial function y equals x to the n, then the integral of y dx, this is how you write it, is equal to the integral of x to the n dx. And so the general definition says that just add 1 to the power, then after that divide the whole of your answer by n plus 1. Now this is the case. Okay, we could have stopped here, but the problem is we are saying that the function that we are integrating is actually some function or some differential. Okay, meaning that we actually differentiate some function, and then we had this function here, and so we want to find a function back. That is why we are integrating. Okay, so it's like differentiation and integration, they are of opposites to each other. Okay, some books will tell you that integration is called antiderivative, that is the opposite of derivative. Okay, so we said in our video that if you differentiate a constant, okay, if I have a constant c, and if I differentiate this, let's say y is equal to this, then dy dx is actually equal to 0. So it means that if I have y equals, let's say, x to the n plus c, then dy dx is actually equal to nx to the n minus 1. Okay, now if you integrate this, you have to get this function back, but after integrating you could see that you will get something like x to the power n after integrating this whole thing here, because it is nx to the power n minus 1. We did it just now. Okay, but why is that? See, this means that the original function was having some constant in it, which one we differentiated we had 0. Okay, so what we'll do is, after every integration, once you've not given any limits, okay, we'll talk about the limits of integration very soon. Once you've not been given any limits, then after every integration, just integration raw like this, what you do is just add a constant c to it. Okay, so you add some constant c. So this will be a general definition for integrating polynomial functions. So in this case, we have a polynomial y of n, that is a polynomial of order n, s to the power n plus x to the power n minus 1. Let me write it well. Okay, all right, so keep it in mind, okay, that this is our general definition for integration. Okay, so now let's look at something. If I have a polynomial of order n, okay, that is ax to the power n plus bx to the power n minus 1 plus cx to the power n minus 2 plus that's plus, let's say, k s to the power 1 plus, let's say, l. Okay, where our l is a constant this time. The integral of yn, that is this polynomial of order n, is actually integrating. This will be equal to integrating every term, okay, ax to the power n dx plus integral of bx to the power n minus 1 dx plus integral of cx to the power n minus 2 plus integral of dot 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 like that plus the integral of kx to the power 1 plus all of them dx, okay, dx integral of L dx, okay. Alright, so this is how the general formula is. So it means that if I'm integrating a polynomial which constitutes of summation of terms of x, okay, then I have to just integrate them term wise. Alright, so this will be our basic definition for integration. Let's all keep it in mind and start working with an example, okay. Alright, so let's take an example, okay. Let's write the integral definition first. The x is actually equal to x to the n plus 1 over n plus 1 plus c, okay. So let's look at this situation where we don't have any limit on our integrals, okay. So you should always remember that this definition only works for polynomials. I'm repeating this again. It only works for polynomials, okay. So it can be a polynomial of variable, let's say u. If you have u to the power something du, it's okay. But once you move out of polynomials to, let's say, trigonometric functions, logarithmic function or exponential functions, the technique will change, okay. So we look at them, but for now let's focus on polynomials and deal with them, okay. So now, how do I differentiate, how do I integrate this? If I have a function of, let's say, y of x is equal to x plus 1, okay. Alright, or let me start with x, okay, so that's next time I add a plus 1. How do I differentiate this? How do I integrate this? The integral of x dx, so it's like picking the function and putting it here, right? Just put it here. Now the power n is what? 1, okay, so it becomes x to the power 1 plus 1 over 1 plus 1, okay, then plus c, and this will give us what? S squared over 2 plus c, okay. So from the basic definition, this is what integrating x will give you, okay. Alright, now let's move on to a very tricky one, okay. What if I have y of x equals, let's say, 1 or a certain constant a? Let me put 2 there, okay. How do I go about this? Remember, if I say it is in terms of x, it means the power of x was what? Okay, let's look at something. If I attach this by x to the power 0, have I changed anything? No, because x to the power 0 is 1. So actually, any constant in terms of polynomial is just the constant times the polynomial variable to the power 0, okay. So let's see, how do I integrate this? Now there was one thing I forgot. If you have a constant attached to a polynomial or something like integral of, let's say, ax to the power n, this will actually give you the a times x to the n plus 1 over n plus 1 or plus c, okay. So it's just that your a will multiply only this part, okay. Let's see, we'll talk about it. Alright, actually that is how it goes about, okay. Alright, so looking at this, the integral of y of x, where y of x equals 2, which is the same as 2x to the power 0, then the integral of 2x to the power 0, the x will give us factoring the constant out, then x to the power 0 plus 1 over 0 plus 1, okay, plus c. Now this is equal to what? X to the power 0 plus 1 is x to the power 1 over 1 is the same as x to the power 1. So it becomes 2x plus c. So this is the outcome. Anytime you integrate a constant, you get 2x plus c. Okay. So now quickly, if I have integral of integral of 3 dx, this is equal to 3x plus c. Hope you can see that. Integral of 5 dx, this is equal to 5x plus c. So if I have integral of 1000 integral of 1000 dx is the same as 1000 x plus c. Okay. Since we are okay with this, let's try to pick another function and differentiate. Okay, so y of x or f of x is equal, let's say 3x squared plus 2x plus 1, and we are supposed to integrate this. Okay, then the integral of 3x squared plus 2x plus 1 or what dx is the same as we said, picking them and integrating them term wise. Okay, plus integral of 2x dx plus integral of 1 dx. Okay, now this is equal to, this will give me what, 3 out, then x to the power 2 plus 1 over 2 plus 1. Okay, plus c for the first one, then plus 2 out, let me write it well, 2 out x to the power 1 plus 1 over 1 plus 1 plus c, then the last part plus 1x plus c. That's what we just did. Okay, now if you could see, there is a c. Alright, you can add them and call them 3c, but a 3c is still a constant. Okay, so we can also call the whole 3c as a capital C. Okay, so in other words, what we mean is that alright, so doing this, if I multiply the whole of this through, I'll get something like 3s cubed over 3, then plus, I'm just going to add all the c's. Okay, 2s squared over 2 plus 1x, that is x, or plus 3c, and that will be what we're saying, that let's call it a capital C, that is a constant. So in other words, if you are integrating a function that contains a lot of polynomials with different degrees, that is like this one, that they are being separated by either addition or negatives or subtraction, you just have to integrate them term wise. Then after all, you add a capital C here to all of them. Okay, so now our integral, we can still go on and then do some simplification here. Okay, so this is what we had. We said after everything, if I divide 3s cubed by 3, I'll get s cubed plus s squared plus x plus what, c. So this will be our final answer. Alright, so I hope this is very clear, right? This is very, very simple when it comes to addition, subtraction, and the rest. Okay, alright, so you can use basically this idea for every integral of polynomials. Okay, so let's look at one special case. Okay, let's look at one special case and you would understand now. So we said that if you want to integrate any polynomial function, this is what you use. Okay, so let's see. What if I have something like integral of 1 over s squared dx? Then I can simply take the x squared out from indices and we apply our rule. Okay, so integrating this, we just add 1 to the top, then negative 2 plus 1 plus c, and this will give me what, x to the negative 1 over negative 1, okay, plus c. So this is actually going to be negative 1 over x plus c. If you could manipulate your indices, this is what we will get, okay. But what if this function is not like this and it's like 1 over x dx? Okay, let's use our rule and see. This will give us what? Integral of x to the negative 1 dx. So if you are to integrate, it will be x to the negative 1 plus 1 over negative 1 plus 1 plus c. But negative 1 plus 1 will give us 0, and we'll get something like x to the 0 over 0, which this does not exist in mathematics, okay. So then we have to know some basic definitions of integration. Okay, if you know your differentiations very well, you know that if you differentiate the function ln x, you get 1 over x. And we are saying that integration is finding functions that are opposite to differentiation. Okay, so it's in such a way that that function, when you differentiate, you get this function back. So if I have 1 over x, then the question is, what function did I differentiate to get 1 over x? So that is what about integration. Okay, so integration is just asking us the function that when you differentiate, you get 1 over x. Alright, so another definition is that if I have a function just 1 over x, okay, like this, the integral will give me ln of x plus c. But the question is, what if I have integral of 1 over x plus 1? Okay, we'll talk about this later. This also will take ln x, but or ln of the denominator. But then, since we are not strong enough, let's go through it step by step. Okay, sometimes some functions will be given, and then let's say we'll be given something like integral of, let's say, some f of x over g of x. Okay, with this definition will fail here. Okay, so this is what this means. Sometimes let's look at the other case. Sometimes we can get something like a over, let's say, square root of some s squared, either plus or minus a squared. Then sometimes too, it can be integral of some b over let's say square root of s squared plus or minus a squared, meaning the denominator, this a, and here this a and this a are the same, but here this and this are not the same. Sometimes you can get some a over square root of a squared minus s squared, okay, and sometimes to this a wouldn't be the same as this a. So with all those in mind, how do we do the integration? Okay, so in our next video we'll look at the techniques of integrating polynomial functions. Okay, but for now, let's have in mind the small and basic definition of this and this definition. Okay, so kindly subscribe to my channel, because in our next video we're going to start with techniques of integrating polynomial functions. We have so many techniques that we'll talk about: the substitution rule, we talk about what we call a partial fraction, and we talk about the trigonometric substitution. Okay, alright, so these three techniques are what we're going to do with in our next video. Okay, so in our next video we'll talk about the substitution rule, then our subsequent videos we'll talk about partial and then trigonometric substitution. Alright, so thank you and see you next time.